Hi everybody, so today we are going to take a look at the answers to questions 11 through 20 from your final exam review packet. In number 11 it says the area of a square is 200 square centimeters. So I've got a little square with 4 congruent sides, each side having a length of s, and then we have the diagonal, which we'll call d. So we have to find the length of that diagonal. So the first thing we have to do is work with the area in order to find the length of each side. So the area would be equal to the side squared, because length times width is how we'd find the area. So set 200 equal to s squared, and then take the square root of both sides. Now on the left hand side, when we simplify that, factor it into 100 times 2. The square root of 100 is 10. So we have 10 square root of 2 for the length of each side. So this side is 10 square root of 2, and this side is 10 square root of 2. Now keep in mind that this is an isosceles right triangle, or what we can call a 45-45 right triangle. So the length of D, the diagonal, can be found by taking the side of 10 square root of 2 and multiplying it by the square root of 2. So we get 10 square root of 4, and that will simplify to 10 times 2. So the length of the diagonal is 20 centimeters. Now, you could also find the length of the diagonal by using the Pythagorean theorem. Okay, the next few questions involve using trig functions. So recall that we use the little saying so, ka, toa, to help us remember our 3 trig functions. The s stands for sine, and it's equal to the ratio of the opposite side over the hypotenuse. The c stands for cosine, and it's equal to the ratio of the adjacent side over the hypotenuse. And finally, tangent is equal to the ratio of the opposite side over the adjacent. So take a look at where your angle is in number 13. 19 is the side opposite to that, and 6 is the adjacent side. All right, we're not going to use the hypotenuse, because notice that it's not labeled with any numbers. Okay, so I'm just going to take the hypotenuse completely out of there. So if we're dealing with opposite over adjacent, we need to work with tangent. So we will write the equation as the tangent of x equals 19, the opposite side, over 6, the adjacent side. Okay, so when you are looking for an angle, as we are in here, this is where you need to use the inverse tangent. So say x equals tangent to the negative 1 of 19 divided by 6. So again, that's called the inverse tangent. Go to your calculator and type it in. So you just press second, tangent, 19 divided by 6, and hit enter. And then it says that we want to solve to the nearest degree. It comes out as 72.47. So to the nearest degree, we'll say 72 degrees. Okay, number 13. It says use the diagram to find the sine of x as a fraction in simplest form. So recall that we just reviewed our 3 trig functions. Sine is opposite over the hypotenuse. So the sine of x will be equal to the ratio of the opposite side, 8, over the hypotenuse of 17. So 8 over 17 is our final answer. No need to find the angle. It just says, the directions just say to find the diagram, to use the diagram to find the sine of x as a fraction in simplest form. So this is it. Okay, in 14 and 15, we have more trig. And so 32 degrees is our angle. We have to find the length of that side, x. That's the adjacent side to our angle of 32. And 11 is the label in the hypotenuse. Adjacent over hypotenuse leads us to cosine. So we would write the cosine of 32 degrees equals x over 11. Now, if you recall, when we did this lesson, we treated this as a proportion. Put the cosine of 32 over 1, and then as in most, pretty much every proportion, we cross multiply to solve. So x times 1 gives us x, and then take 11 and multiply it by the cosine of 32. Should get in the habit of having that 11 out in front rather than cosine of 32 times 11. And the directions say find x to the nearest tenth, and it comes out to be 9.3. Okay, number 15. So 28 degrees is our angle. 21 is the opposite side because you go all the way across the triangle to get there. And x is the label on the hypotenuse. Opposite over hypotenuse leads us to sine. So we would say the sine of 28 equals 21 over x. Okay, this is going to take us an additional step to solve because x is in the denominator of the fraction. Okay, we still cross multiply, and when we do that, we'd get x sine of 28 is equal to 21, because 21 times 1 is just 21. We're working to get x alone. This is multiplication. Undo that multiplication by dividing by the sine of 28. And do that on both sides. Okay, now we have x equals 21 divided by the sine of 28. And you're going to head to your calculator to do that. And again, we need to round to the nearest tenth, and the answer is 44.7. By the way, make sure that your calculator is in degree mode. If you're not sure how to check it or how to switch it, please let me know. Okay, number 16, we have another trig equation. So for 28 degrees, x is the label on the opposite side, and 25 is the hypotenuse. And we have to solve for x to the nearest tenth. Opposite over hypotenuse leads us to sine. So say the sine of our angle, which is 28, is equal to x over 25. Okay, put the sine of 28 over 1, cross multiply, and we get x is equal to 25 sine of 28. Okay, go ahead and go to your calculator. 25 sine of 28 to the nearest tenth will be 11.7. 17 through 20 are all trig functions or trig equations that come from applications. So we're going to have to draw a picture for these. It says a slide 3.5 meters long. So imagine a slide. All right, so here's the ladder to go up to the top of the slide. And this slide makes an angle of 32 degrees with the ground. So this is the ground on the playground. We're going to assume that the ladder is perpendicular to the ground. And we have to figure out how high the top of the slide is above the ground. So we want to know the height of the ladder. Okay, so take a look. Your angle of 32 degrees, x is the opposite side. 3.5 meters is the hypotenuse. So we want to work with sine. Sine of 32 equals x over 3.5. Put the sine of 32 over 1 and cross multiply. We get x is equal to 3.5 sine of 32. You're ready to go to your calculator, and when you do so, you'll find out that it's equal to 1.9 meters, rounded to the nearest tenth. Okay, number 18, it says Lila drives 16 kilometers up a hill. So this is a road going up a hill. She drives 16 kilometers up this hill. That is a grade of 14 degrees. So this angle right here, it's an angle of elevation, is 14 degrees. And we're asked to find the horizontal distance to the nearest tenth of a kilometer that she's covered. This would be the horizontal distance. This over here would be the vertical distance. So we're solving for x. For that angle of 14 degrees, x is the adjacent side, and 16 kilometers is the hypotenuse. Adjacent over hypotenuse leads us to cosine. Sorry about that. Try again. So say cosine of 14 degrees equals the adjacent side x over the hypotenuse 16. Okay, cross multiply. 1 times x gives us x, and x is equal to 16 cosine 14. You're ready to go to your calculator, so type it in 16 times the cosine of 14, and the final answer is 15.5 kilometers. Okay, number 19, it says a lookout spots a fire from a 27-meter tower. So this person is up in a tower, 27 meters above the ground, and they look down and they see this fire. It says the angle of depression from the tower to the fire is 23 degrees. So angle of depression would be from their line of sight if they looked out towards the horizon and then they changed their line of sight to look down at the fire. That angle is your angle of depression, 23 degrees. But that's the same as the angle of elevation from someone who's down on the ground at the fire looking up at the tower. Those two angles are equal to each other because they're alternate interior angles formed by parallel lines, so they're congruent. Okay, it says to the nearest meter, how far is the fire from the base of the tower? So we're looking for this distance. The base would be the bottom of the tower. So 23 is our angle, 27 meters is the side opposite that angle, and x is adjacent. All right, finally, we're working with tangent because we have opposite and adjacent. So you want to say the tangent of 23 is equal to 27 over x. Anytime you have x in the denominator, it's going to take another step to solve for that x. So it's not just a one-step proportion to solve, we need two steps. So cross multiply, and we get x times the tangent of 23 is equal to 27. Divide both sides by the tangent of 23. And you have x is equal to 27 divided by tangent 23. And go ahead and go to your calculator and divide that out. 27 divided by tangent 23, and that's equal to 64 meters. I don't know what just happened there. Okay, one more in this video, so last question. Okay, number 20, it says a large totem pole near Kalama, Washington is 157 feet tall. Okay, so it's like a tower, big carved totem pole, 157 feet tall. At a particular time of day, it casts a 237-foot shadow. So the sun would be shining up here somewhere, hitting that totem pole, and then its shadow would be along the ground. And since a shadow is on the ground, that's how we can measure it. So we know for sure how long it is, 237 feet. And this is 157 feet. I wrote meters. Okay, it says what is the sun's angle of elevation at that time? So assume that the totem pole is perpendicular to the ground. Angle of elevation would be this angle x, like if you're standing at the tip of the shadow looking up at the sun. Okay, so from the position of x, 157 is the opposite side, 237 is the adjacent side. So that's how I know we want to work with tangent. So you have tangent of x equals 157 divided by 237, or x is equal to tangent -1, inverse tangent, because we're looking for an angle, and that's why you have to use that inverse tangent. So inverse tangent, or tangent -1 of 157 divided by 237. Okay, go to your calculator. When you type that in, you should end up with 33.5 degrees. We'll just round it to the nearest tenth. It doesn't specify in the problem.